All right, guys, this is the video introducing you to the operation called a logarithm. Now, the word logarithm, that was created, I just looked it up, in 1614 based on some Greek words. All that it means, it's a placeholder, a word for an operation, just like multiply, divide, and exponential, okay? So it sounds harder than it is. Now, a logarithm is the opposite operation of exponential. It is the inverse operation, okay? Just like multiply is the inverse operation to divide, just like add is the inverse operation to subtract. So, in order to solve an exponential, meaning in order to solve for a variable that is in an exponent, you need to perform a logarithm. So what we're going to do now is we are going to perform the logarithmic operations. Now how this works is you have a base number. That is a number that is in subnotation. It is lower than the log. And then you have another number called the argument. This is on the same level as the log word. What you're asking for here is what number or how many times do you multiply the base times itself to get to the argument? So here in this first problem, problem number 1, how many times do we multiply 2 times itself to get to 8? So let's try it over here. 2 times 2 is 4. Well, that's not quite there yet. Times another 2, that's 8. So how many times did we multiply 2 by itself to get to this 8 number? 3. So log base 2 of 8 is equal to 3. Okay, let's try this again. So now, looking at number 2, we have log base 3 of 9. So now our base is changed to a 3. And our argument is now 9. So we have to ask ourselves, how many times do we multiply 3 times itself to give us 9? So let's try it over here. 3 times itself is just 9. So how many times did we multiply 3 times itself to give us 9? 2. There are 2 3's multiplied together to give us 9. So that means log base 3 of 9 is equal to 2. And one last time, we have log base 5 of 625. So this one is quite a bit larger. So we have to ask ourselves, how many times do we multiply 5 times itself to give us 625? 5 times 5 is 25, so we're not yet there. Times another 5 is 125, still not there. Times another 5, well, that is 625. So how many times did we multiply 5 times itself to give us 625? 4 times. We multiplied 5 4 times to give us 625. So log base 5 of 625 is equal to 4. Now, that's all you need to know in order to know how to evaluate a log. But you might be asking yourself, why did we do this? When do we use log? Why are we asking ourselves this? What we're asking ourselves again, how many times are we multiplying, if I'm looking at number 1, how many times are you multiplying 2 times itself to give you 8? This question is the same as writing 2 to the power of x is equal to 8. So if you saw this, 2 to the power x is equal to 8, you, again, in your head, ask yourself, how many times do we multiply 2 times itself to give us 8? Oh, Well, 2 raised to the power of 3 is 8. This means x is 3. That's the exact answer we got over here. On number 2, another way to write this is 3 raised to the power of x is equal to 9. What does x need to be? What does that exponent need to be in order to have 3 raised to it equal 9? Well, here 3 raised to the power of 2 is 9. So here x is 2. And then lastly, another way to write number 3 is 5 raised to the x power is equal to 625. So we ask ourselves, what power do I raise 5 to be 625? You raise 5 to the power of 4 to give you 625. So the reason why we would have to use log is if we have a variable in the exponent, which we know from Algebra 1, a variable in the exponent, this is called an exponential. So in order to solve an exponential, the opposite operation is log.